Okay, before we get into the assignment, I want to review some information. You have to solve this inequality and graph your solutions. So we have the equation, inequality, negative 2x minus 4 is greater than negative 16. Okay. Now, when solving inequalities, we need to make number lines before we solve them, 0 in the middle. Now, I find what's called the critical value. So, here's the symbol. X is on this side of the symbol, and the operations are a times and a minus, means plus negative. Now, you want to highlight your multiplication number. The reason why we do that is because I'm going to eventually have to divide both sides by that number, and when I divide both sides by a negative, which this is, the sign needs to switch. So the sign goes the other way. But before I divide, I need to take out the outside number that's being added. And when I'm taking that number out, the sign will stay the same. Okay? So it stays the same when you add or subtract, but it changes if you divide by a negative. Now, if that was a positive 2, these would both be the same, but it's not. So we add 4. We have negative 2 times x, and then negative 16 plus 4 is negative 12. Now, when I divide by a negative, the inequality flips. Not just divide, it's got to be by a negative, which I am. And that's 6. Okay, so you have 6, you circle it. Now, question is, what's it eat? It's eating the 6, so it's eating the numbers, so that means it goes this way. We leave the circle empty because it's not filled in. Okay, and then I label it with my solution. X is less than 6. Okay, next one. 14x plus 9 is greater than 3 parentheses 5x plus 3. So, I set up my number line. Well, before I really pay attention, I got to undo the parentheses, get that out of there. So we have a plus inside, so I have to distribute 3 times 5x, 3 times 3. So I'm going to drop that plus straight down. 3 times 5x is 15x. 3 times 3 is 9. And on the other side, we have 14x plus 9. Now, you have x's on opposite sides, so you mark the smaller, or mark whatever one you want. I'm going to do 14. So I take that out, minus 14x, minus 14x, line it up. Okay, 15x minus 14x is x. It'd be 1x. But if you end up with a 1 in front of the x, you can cross it out and just put x. If it's a 1, it has to be a positive 1. Okay? And then plus 9. So that's interesting. Okay, now x is on this side, and it doesn't have the multiplication or division operation at all. I mean, it would have been a 1, but I don't really need a 1 because having a 1x is just kind of pointless. So we're not going to have to switch the sign because we don't even have multiplication or division. Okay, we just have addition. So the sign will stay the same because I will not be dividing by a negative, certainly. I just will be minusing 9. So you have x over here. 9 minus 9 is 0. So you don't need to make another number because 0 is here. So the circle goes above that, and it's eating the number value. So when it's eating the number value, again, it will go this way. Okay. Okay, next problem. Negative 1, x minus 3, and then less than or equal to 2. So we have 2 symbols this time. Okay. So with 2 symbols, I make a table, okay? And then what I do is I drop the first symbol. On this side, you got negative 1, and then on the other side, you have x minus 3. Then you drop the other symbol. You have 2 on this side, and on the other side, you have x minus 3, okay? Now you solve them each separately. So x is on that side. What operations? Well, I have a minus, x minus 3. So there's no multiplying or dividing at all. Okay? So the sign will stay the same. Remember, the sign switches if you multiply each side by a negative or divide each side by a negative. But since we don't have multiplying or dividing, we don't have to worry about it switching. Take out your negative 3 by adding 3. And we have x here, negative 1 plus 3 is 2. Meanwhile, on the other side, same thing. No multiplying or dividing, so the sign will stay the same. We take out the negative 3 with a plus 3. We have x and 5. So we have 2 and 5. Circle both, fill them in. Okay, eating the x. Now remember, when it eats the letter, it goes this way. Well, then we're going to go back the other way, and what we have is a compound inequality. Okay, so I put x, I put 2 on this side, I put 5 on this side. Now this is the highest number you can get to, so you want to eat that number. This is the lowest number, but don't eat that. You never eat the low number, you eat the x in relation. Okay, and then we put the lines underneath because they're filled in. Okay, next problem. 2x less than or equal to negative 4, or 7x greater than or equal to 49. So, you again want to make a table because you have two signs. But filling it out is fairly easy. You have 2x, and then the symbol negative 4. And over here you have 7x greater than or equal to 49. Make your number line. So what operations do you have with x? You have a 2. What's the operation? It's times. Aha, so I like to circle those times. Now that's a positive, so we will keep the sign the same since I will be dividing by a positive. Now you don't have to have a middle step because you don't have anything outside being added. You go straight to division. So you have x here, negative 4 divided by 2 is negative 2. Okay. Okay, you have the multiplication here, but again, that's positive 7, so we're going to keep the sign the same, and I don't have to go to a middle step because there's no adding or subtracting. I just need to take out the 7 by dividing. So x, 7. So the two values are negative 2, positive 7. So you circle, fill it, and then you circle the 7, fill it. X and negative 2, it's eating the number value. So eating the number goes this way. Well, then guess what happens here? It goes back the other way. So I write the word or, and then just put x less than or equal to negative 2, and then x greater than or equal to 7. Okay. All right, now, here's a new thing you're going to do. Solve the inequality and graph your solution. Now, you have this absolute value of x. It's x with two braces around it, and then less than 5. Now, here's what an absolute value means. It means distance from 0. Exactly what that means. When we have an absolute value inequality or an equation, whatever, you want to make a table, but you want to make it over here. Now, here's what you're going to do. You're going to put what's inside the absolute value function on each side of the table. Okay. Just put that down here. Then you are going to replace your absolute value function with d. D stands for distance, distance from 0. Now, d less than 5. Well, d's isolated, okay? It's by itself. But have an absolute value at 5, you could be at 5 or negative 5. Now the symbols you put the given symbol here, but you flip it on the negative side. And then you're good on that problem. Okay, you know exactly the two numbers to plot. So 0, so I put 5 on one side, negative 5 on the other. Neither circle is filled in because the lines are not there. So with x and 5, it's eating the number. Okay, so that would be this way. Well, then we're going back the other way here. It has to be within 5 from 0. That's what less than means. You put x, you put negative 5 on this side, positive 5 on this side. You eat the bigger number, then you eat the x. Okay, next problem. The absolute value of x greater than or equal to 2. So I see that absolute value, okay? So whatever's inside the absolute value, you've got x and x, okay? Now replace the entire absolute value function with d, because that stands for distance of 2. 2. Distance of 2, you could be at 2 or negative 2, because that's what's inside. So I use the given symbol on the 2, but I flip the symbol on the other side, okay? And you pretty much have the two numbers that you're going to plot, 2 and negative 2. So 2, negative 2. So this time both circles are filled in. Here it's eating the x, it's eating the letter, so it goes this way from the 2. Okay, so then it's going to go this way from the negative 2. So you write or, and then write each one separately. You don't combine them like you did there. Okay, next problem. We have the absolute value of x plus 8 greater than or equal to 3. So, when I see that absolute value function, I make a table, okay? And whatever's inside the function, I write on each side of the table, because an absolute value has two possibilities. That's why you got to count twice. Now remove the entire function and put d, so d greater than or equal to 3. So again, you could be at 3 or negative 3. Now we use the given symbol on the 3, but then we flip the symbol when we do the negative 3. But on the number line, we don't have our numbers yet because we got operations with the x, unlike the last two problems. So you don't have the multiply or divide operation at all, so you're going to keep the sign the same. Then you minus 8, and you have x, 3 minus 8 is negative 5. Do the same thing here. Again, the sign will stay the same. Minus 8, negative 3 minus 8 is negative 11. So now we have our two numbers. They're both negatives, negative 5, negative 11. So circle, fill it. Then negative 11, you circle and fill it. So with negative 5, it eats the x, so that goes this way, and then this one's going to go the other way. Then you write or, and you put each solution set separately. Okay, my next problem, we got the absolute value of x minus 2 less than or equal to 1. So whatever's inside, that expression goes on each side of the table. This time there's an operation with the x. Okay. Now remove the absolute value, and let's talk about distance. Now to be 1, you could be at 1 or negative 1. So you use the given symbol on 1, but you flip it on negative 1. And now we solve them separately in graph. Okay, what's the multiplication or division operation? You don't have it, so you'll keep the sign the same. Remember, the sign will switch when you multiply or divide by a negative. So plus 2, x, 3. Here I don't have to multiply or divide, period. Okay, so no multiply, no divide, that's a keep. And then plus 2, negative 1 plus 2 is 1. Okay, so the critical numbers are 3 and 1. Both will be filled in. So let's talk about the 3. It eats the number value, so that would go this way, well then this would go here. Okay, so x can be all values between 1 and 3. Okay, so I put x, I put 1, 3. Remember, you eat that. 3 is your highest value, 1's your lowest. You never eat the lowest, only the highest. Okay, next problem. The absolute value of 2x minus 5 is less than 9. Okay, so when I see that absolute value, I want a table to the side, not below it. Okay, and whatever's inside, I put on each side. 2x minus 5, 2x minus 5. Now remove that from your thing, and you have d less than 9. So you got the absolute value is 9, 9 or negative 9. And you use the given symbol on the 9, but you flip it on the negative, and you solve each one separately. Because these are compound inequalities, you just don't see them right off the bat. So now x has two operations on its side, okay? You got a times 2 and a minus 5, make that plus negative. Highlight the times. If you got times or divide, you really need to circle that, and that's what I call highlighting it. Now that's a positive 2, so we will be keeping the sign the same, because when I divide it will be by a positive and not by a negative, so that symbol will stay the same in the end. Now I do have to have a middle symbol because I have to add the 5. Okay, so plus 5 plus 5. 9 plus 5 is 14, and you have 2 times x. Then you divide each side by 2, and I'm dividing by a positive, which is why the sign is not changing. Okay, over on the other side, same thing. Not going to be any different, plus negative. Once again, we will keep the sign the same, because when I do divide, it will be by a positive. Take out your negative 5, okay. So that's going to be negative 4, and then 2 times x. Then I divide each side by 2. We have x, negative 2. Okay, so I have positive 7 and negative 2. So circle, eats a number with 7, eats the letter with x, so they go connect. Negative 2 is the minimum, 7 is maximum. You eat the high, then you eat the x. Okay. Next one, the absolute value of 3x plus 1 is greater than 8. So within the absolute value, we have the expression 3x plus 1. So I replace the absolute value function with d, so d greater than 8. So you can be greater than 8 or less than negative 8. So you got to flip it. Now, x has 2 operations, a times and a plus. So highlight the times, but if it's by a positive, we're going to keep the sign when we divide. But first I have to subtract. Okay. So 3 times x. 8 minus 1 is 7. Then I divide each side by 3. Now that's going to be a decimal, so I'm going to just write 2.3. I'm just going to repeating. Okay. The other side, same thing. Times and plus. The times is with a positive, so that means this symbol, when I divide, will stay the same, because when I divide, it will be by a positive. You take out your plus 1 with minus 1. Negative 8 minus 1 is negative 9. Then I divide each side by 3. I have x with negative 3. So the critical values I have are 2.3 repeating, positive, and then negative 3. Okay, so you eat the x, that's this way. Then you eat the number, that would be this way. So I write or, and then just write them separately. That's how you label them when they go apart. Okay, 2 more left. The absolute value of 4x plus 1 is greater than 11. Okay. So, 4x plus 1 is your inside expression. Remove the absolute value function, replace it with d. Okay, distance of 11, you could be at 11, or you could be at negative 11. Now you solve it. Okay, you have times 4 and plus 1. The times is by a positive, so once again I will be keeping it. If that 4 was a negative, I would be switching it, but it's positive. First I have to take out the plus 1 though. It's going to be 10 divided by 4, divided by 4. 10 divided by 4 is 2.5. The other side, same exact thing. You keep the sign the same, because when you do divide, it's going to be by a positive. Minus 1, minus 1. Negative 11 minus 1 is negative 12. Then you divide each side by 4, and you have x, negative 3. So we have reached our 2 critical values of 2.5 and negative 3. So at 2.5 it eats the x. Well, I gotta switch batteries here.